Today, with the growing popularity of new computing form factors like smartphones and tablets, it is increasingly likely that users own two or more computing devices. Unfortunately, the majority of applications on these devices currently work independently. As a result, often users work with only one device at a time and are unable to take advantage of the computing power of all their devices. Wouldn't it be great if developers could easily write applications that span across multiple devices? Wouldn't it be great if these applications could shrink and grow to take advantage of all the user's devices? Enter Panelrama, our HTML5-based framework allowing multiple devices to interact simultaneously with the same web application. Panelrama is built around the idea of panels, groups of UI elements that stay together when distributed across devices. For each type of panel, Panelrama provides developers with the ability to add, remove, clone, or transfer these panels to any connected device. In this Maps application developed using Panelrama, a user discovers that the smartphone is too small to conveniently give directions on a map. This is solved by transferring the Maps panel to a larger screen, but retaining the control of the map via a navigational panel remaining on the smartphone. Cloning the map panel gives a synchronized map for finer control. Panelrama offers developers three major benefits. 1. Panel state synchronization. 2. Automatic panel allocation. And 3. A simple developer experience. Panelrama provides developers with state synchronization across multiple devices through a global panel state for panels of the same type. Local panels on devices could choose to be synchronized and identical to the global state, or desynchronized and only update on demand. Naturally, the global panel state need not be completely synchronized. In this map application, we use the global map panel to synchronize the local viewports of 3 tablets, but not the type of map being displayed, allowing each map panel to provide different information on the same location. Similarly, a Street View application could synchronize the GPS coordinates, but not the viewports, making it possible to achieve a panoramic view of the road. Panelrama also allows this PDF reader to display consecutive pages on additional devices. Synchronization ensures that all pages flip simultaneously, while an unsynchronized device can be used to display a helpful diagram or a list of citations. Unsynchronized local panels may access the global panel on demand. In this video player, a user uses the push function to broadcast a local video to the global panel for group viewing. Other users may use a pull function to copy the global panel contents to their local panels for private interactions. Panel synchronization is well and good, but not all panels are equally suited for all devices. Some panels are well suited for large screens, some for devices close at hand, some for scrolling touchscreens, and some for keyboard-enabled computers. As the number of devices increases, it is overwhelming to ask the developer to manually specify an optimal distribution for every panel. This brings us to Panelrama's second helpful feature, automatic allocation of panels to suitable devices to maximize an application's usability. For each type of panel, the developer scores the importance of certain device characteristics to the operation of this panel, such as physical size for content-rich panels, keyboard quality for text input panels, or proximity to the user for remote control panels. Given this developer definition, Panelrama's optimization algorithm finds a panel distribution that maximizes the application's usability and reassigns panel locations whenever new panels or devices are added. To demonstrate, suppose we are browsing YouTube on a laptop. All of our panels are located here. Connecting a TV to the session causes the video panel to relocate to the larger screen, while a device closer to hand receives the media controls. A larger device like a tablet would be allocated all the UI controls to minimize switching between devices. Panelrama applications not only look impressive, but are also easy to construct. Using existing web technologies, Panelrama allows existing applications to be converted with minimal changes to the code base. Conversion of an existing application to Panelrama follows 3 steps. Let's try this with a simple example using a drawing application with a canvas to draw upon and 3 buttons to pick our colors with. First, it is necessary to split the application's HTML into multiple templates, each with a panel tag. We see here that the HTML elements copy over exactly, with only minor modifications required to define the panel types and IDs. Next, we need to make changes to the JavaScript business logic of the application. Code which relies upon the DOM elements or event handlers are placed under the rendered events of each panel template. Minor changes need to be made to any code that accesses state variables in synchronized panels. Naturally, functions that do not access synchronized state information do not need to be changed. Finally, and most importantly, developers need to define the definitions of the panel, including its name, its automatic allocation scores, and any state variables that need to be synchronized. When all three steps are completed, we have successfully converted the application to make use of Panelrama, reusing the majority of our application and making only minimal changes.